Good day everyone, my name is Rinaldo C. Rodriguez Jr. Together with me is Marife Gahisan. And now, as a requirement in our subject meteorology, we are going to make an experiment or to do an experiment. Since we can do it in our school due to this pandemic, and we are now here in our new normal, we are studying at home. And by this experiment, we are doing it in our homes. But before we proceed, we should stay safety. Should follow the safety protocol set by our Department of Health in order to be COVID-free. And now, we are going to do the experiment.
Good day everyone, my name is Marife Gahisan and I will going to read the instructions on how to do the experiment. First, place the flashlight holder on the flat surface and then attach the flashlight into the holder. Take note that you can use two thick rubber bands to attach the flashlight into the angle adjuster. Next, the position of the flashlight at 90 degrees angle so that the light rays contact the surface directly overhead. Take note that this corresponds to a 90-degree solar elevation angle, meaning that the sun is 90 degrees from the horizon, or example, directly overhead. Then the angle of the incidence is read using the degree mark of the protractor at the nail. Then you turn on the flashlight and use the ruler to measure the surface area covered by the light rays at this angle. For the best results, dim overhead lights in the room before turning on the flashlight. Then you record your results and turn off the flashlight. Next is you need to rotate the flashlight to a 60-degree angle. Turn on the flashlight and measure the surface area covered by the light rays and then record your results. Next, rotate the flashlight to a 30-degree angle. Turn on the flashlight and then measure the surface area covered by the light rays at this angle. Then record your results. Then after that, turn off the flashlight. So that's all the instructions on how to do the experiment.
Hello guys, we are now here in our experiment. So, we have here the flashlight, the protractor, the cardboard under the flashlight, our innovative flashlight holder. So the first thing we do is we put the flashlight in our flashlight holder. We set the protractor in a 90 degrees, and now we are going to light our flashlight. But before that, we should do our environment. We should off our lights. Okay, we are now ready in our experiment. So first, we set the protractor in the 90 degrees and light the flashlight. At higher angle, the surface area should have the highest temperature because the rays are concentrated in a smaller area. So now we already set our flashlight in 60 degrees Celsius. So now here is our light rays. So it measures 6.5 by 6. So it measures 6.5 by 6. Okay, now we already set our flashlight at 30 degrees. Let us see its rays. And now here is our light rays. Then we measure it. So it is 9 inches by 17 inches. So in this experiment, we concluded that at higher degrees it has a higher temperature because the rays are concentrated in a smaller area. And the lower the degrees, it has the lower temperature because the rays are concentrated in a bigger area. And in our last experiment, which is 30 degrees, it has a very low temperature because the rays are concentrated in a wider area. That's all for our experiment today. My name is Rinaldo C. Rodriguez. Together with me is Marife Gahisan. And we are saying, stay safe and wear masks.